In about 2005, NASA started to procure a UAV to be used for Earth science. And in 2006, the Western States Fire Mission was being flown on Altair, a different UAV owned by General Atomics. And following that, it was decided to move the project to Icana in 2007. We had just started flying some missions, and right about that time, the Zaca fire started up.
The Zaca fire was a major wildland fire that broke out in Southern California. And that was one of the fires that we were early in the period called upon to see if we could provide real-time information to that fire management team.
Providing real-time information to incident commanders during the Zaca fire was the responsibility of the Autonomous Modular Sensor, or AMS. Developed by researchers at the University of California, Santa Cruz, AMS is an advanced infrared and optical sensor, small enough to fly on board the Icana, yet powerful enough to remotely process imagery and deliver it in near real time anywhere in the world.
The Autonomous Modular Sensor System is an imaging instrument. It takes pictures of the ground from an airplane. It sees colors ranging from the blue out into the thermal infrared. It's based on a telescope which looks at a single point on the ground, and then a scanning mirror sweeps the vantage point of that telescope across the scene underneath the airplane, building up one dimension, the cross-track dimension of an image. And then a long track motion of the airplane allows us to build up an image line by line by scanning as we go.
By capturing data across multiple bands of the electromagnetic spectrum, AMS has the ability to not only see through smoke, but also intelligently discern the difference between active fire regions, recently burned areas, and areas of reflected sunlight in an image.
The AMS captures data in 12 color regions across the spectrum. After about 1 micron, about twice as red as the reddest we can see, smoke starts to become transparent. So after about 1 micron, we can see the location of terrain and fire underneath a smoke layer. As we move out farther and farther into the infrared, redder and redder, we reach regions where the temperature of targets stands out. What differentiates parts of the image is what temperature they are.
After the telescope captures the raw image data, the AMS sensor's onboard intelligent processing takes over. A suite of complex algorithms geocorrects the imagery, aligning it with the Earth's surface.
One important aspect of data collection and projection onto a map base is the terrain at which the actual item on the ground is located at. If you're flying over mountains, you have a lot of varying terrain, and so if you don't take the terrain into account, you could have an error of a couple hundred meters from where you think the fire line might be to where the actual fire line might be. So we use digital elevation models with our data to do ray tracing to determine where the pixel is located on the ground.
During the Zaca fire, as we collected this imagery, it was corrected on board the airplane, and then it was sent down through the satellite link to the fire incident commanders directly so that they could actually see where the fire was on a terrain map in 3 dimensions.
We developed kind of some simplified protocols and some simplified visualization techniques to allow that imagery and other ancillary data sets that are important for wildfire management to be visualized in Google Earth. So the data comes in, it drapes over the terrain visualization components of Google Earth, and it allows a disaster management team to basically do 3-dimensional view sheds, to do fly-throughs, to bring in other critical data, maybe like fire weather information, to have that all at their hand in one discrete location.
At a critical point during the Zaca fire, information provided by Icana and the AMS sensor helped fire commanders realize the strategy they were undertaking at the time was not going to work. 2 incident management teams were battling the fire, one from the northeast side, the other from the southwest side.
The strategy that we had attempted to do was to essentially come around both sides of the fire, flank it, and then meet someplace out in the edge. We had decided that on that day that we were going to try to meet on a certain road, and we happened to have the Icona live feed coming into the camp. And we saw that the fire had already jumped that road, and that was not a viable option for my counterpart for us to tie into. I called over to their incident commander. They couldn't see where the fire was at because of smoke. And the Icona was able to project down through the smoke and show that the fire had already burned 400 or 500 acres past their initial control line and that they would have to drop back.
One of the most valuable things about Icona is it provided continuous data. The vehicle can fly for 24 hours, so it's not just getting a quick look once every couple of days. It could literally stay over a large fire like Zaka and provide really instantaneous data.
Anytime you can have accurate real-time information improves your situational awareness. Knowing where the fire perimeter is relative to where your ground troops are deployed, it enhances firefighter safety and also improves your efficiency.
The future for the AMS sensor is very bright, with broad application not only for further enhancements to support wildland fire response, but to also conduct remote sensing activities in support of many earth science research missions.
One of our first applications is likely to be an ocean color application in which we provide data to oceanographers and marine biologists who are studying coastal zone algae blooms, transport of nutrients, the surface temperature of the ocean. Extending the fire work that we've done before, we would like to add more intelligence to the system so the onboard computer can decide what is an interesting image to allow it to acquire and transmit data more autonomously. In the current application, we have 2 operators actually present deciding when to take pictures.
And what we've learned is these types of missions are very useful to the fire incident commanders, and they're very doable. The technology is here today to be able to execute these types of missions, to be able to fly over 1,000 miles away from your launch site, do a whole mission and come back and land the airplane safely. We've proven to the FAA that we can fly the mission safely, and we've shown the fire commanders and all the other people that support the firefighting that a UAV is a very capable tool.